satellite image processing software, and also give you a very brief example on what you are expected to achieve in the software. The introduction to the software itself also include two parts. In the first part, I'm going to give you an overview, a basic introduction to the software, including its overview, its functional modules, its unique features, and some of its typical applications. And in the second half, I will give you more information about the characteristics and the strengths of PyAuthor, especially in the latest version. So I'll start with the software introduction. First, I'm going to give you a positioning or what we thought of this software. PyAuthor is a satellite image processing software which utilize the parallel production processing system that supports the process to be stored in memory during the entire processing process of multi-source remote sensing data. It is equipped with advanced processing algorithms such as its high-precision geometric processing of optical images, joint block adjustment of large area using multi-source remote sensing data, and also with its unique uniform color module. And it also combines with the computer processing technologies such as CPU and GPU joint acceleration, distributed multi-thresholding technologies, and so on. PyAuthor can achieve the high precision and automatic processing of large volume data and meet the needs of data production and processing at different scales. So as you can see from the software positioning, we regard this PyAuthor more like to do the image pre-processing, aerial triangulation, and the production of DSM, DEM, and DOM, and also perform the quality evaluation, especially for large, huge volume of data. There are two types of deployment modes, the standalone version and the clustered version. The standalone version, which is also the version that we are going to provide to you where you can find the location in the instruction document. It is the most commonly seen version that you can run on a single computer. And on the other hand, the clustered version refers to where you have multiple computers and you join them in a LAN environment to have the calculating capability combined to perform dealing with large volume of data. PyAuthor has been widely applied in land resource management, in surveying and mapping, agriculture, forestry, environmental protection, water resource management, and many other industries. So a quick introduction to the functional module. PyAuthor, the latest version of PyAuthor, we have the following functional modules, including the project management, block adjustment, DOM production, DEM and DSM acquisition, process production, and finally, quality evaluation. So in terms of the parameter of those functional modules, talking about like this, that PyAuthor supports the multi-source data input. That includes the multiple data of input, such as that's from high or medium or low resolution mainstream optical satellite, and also in terms of some certain types or mainstream types of satellites. It supports the stereo mapping satellite data, such as WorldView, the Ziyuan 3 series, the Tianhui series, the Golfin 6, Golfin 7 series. And in terms of the different types of data, Pi also supports SAR, thermal infrared, LiDAR, vector and raster map data, and many other types. There are some other parameters when talking about functional modules, like it supports the result to be displayed in real time on screen while you are processing the data. And it comes with a very unique human-computer interacting, editing, and interactive interaction algorithms. And it also supports multi-level of parallel processing, and some other functions are displayed. So in terms of the accuracy of the functional module, as you can see displayed on the screen, when you are dealing with matching accuracy, you are that is normally expected within 1 pixel. And in terms of the auto rectification accuracy in plane area, which normally have higher accuracy, it is around 1 to 1.5 pixels, and in mountain areas, it normally gets lower, and that is around from 1 to 3 pixels. Up next, the performance of the functional module. As you can see, some of the examples are displayed. So when talking about real-time display performance, they taking the processing and Golfin 1 image as an example, the average time taken for orthophoto correction is less than 0.1 second per scene, and that for image fusion is less than 0.6 per second, and for true color is normally less than 0.9 seconds. And on the other hand, for the product output performance, also taking Golfin 1 image as an example, the average time taken for multispectral orthophoto correction is less than 5 seconds per scene, and that for panchromatic orthophoto correction is less than 15 seconds. And for image fusion, that is normally less than 30 seconds per scene. And finally, for the automatic mosaic performance, when you are output your results into an SSD, a high-speed hard drive, the speed is the output speed is normally greater than 120 gigabytes per hour. And you have to note that these parameters are only when you're talking about the speed of display, rather than the disk of output into your hard drive, because that's normally limited by the speed of your disk. So in terms of the deployment types, I've previously mentioned, there are a standalone deployment mode, and there are clustered versions. So the standalone version is the most commonly seen that you would like to install on a single computer, and also that is the version that we recommended for general users, which use machine code and Activision license to license to allow users to have access to use the software. On the other hand, the cluster deployment mode, usually you will have multiple, you have many computers joint connected together as in a LAN environment, and combine them to provide powerful combined computing resources to deal with the production of large volume data. And normally in this mode, you are expected to use a U drive to install and have the software licensed. So these are the functional modules that is aligned in the software, and also the layout that a user is normally expected to see in the main interface of the software. So they are categorized into eight groups, and that includes in project management. You can like start a new project or load already existed project and do some modification to your project. And in the pre-processing module, you're expected to convert the format of your data or to do the projection definition. And also you can create pyramid here, which will allow much faster processing in the later on work. And in the block adjustment module, it come up with the connection point matching, control point matching, and also that comes with point measurement and model adjustment. And in the next label, in the advanced image, you can load epipolar or DEM or DOM image. In the image fusion, that comes with some modules where you can fuse different types of image. And in the uniform color, where you can do some color tuning, like either in manual mode or in automatic mode. And finally, in quality evaluation, you are expected to do the product quality evaluation and also do some precise geometric correction. And finally, PyAuthor also comes with a unique function, which is the process workflow. And in here we have a one-click processing button where later on in the actual operation in the software, we're going to use this function to perform a standard, typical, but on the other hand, it's also customizable workflow. So up next in this slide, it shows a typical satellite image processing workflow. It may look like a bit complicated, but please allow me to elaborate to you. So you can see on the left, it shows the boxes in green means those are some processes that supports the parallel processing, which means you can switch the order of doing those. And the boxes in orange means that's where you can choose to do some human-computer interaction or some input. But on the other hand, this is optional. And the boxes in blue means those are the non-parallel processing. And normally that refers to when you have to have an input, or you have to determine like if the accuracy, if the color is satisfied, and you will be able to move on to the next steps. So first, when you want to start an image processing work, you will have to have some inputs. So you will either have some panchromatic or multispectral data as the raw data input. And on the other hand, you will need to have some references like the DEM data and reference data. So you will be able to create a project here, and up next you can choose whether or not to in the pre-processing stage, you can choose to create a pyramid, which will save your time in the later on process, in the later on steps. And you will normally have to create and match the connection point and also the control point. And up next is the plane block adjustment. After this step, if the accuracy is satisfied, you will be able to move on. But if not, you will have to go back and to re-edit the connection point or control point that you have created until you have a satisfied result with the accuracy. So up next, you will move to the pan author rectification and the pan author pyramid creating and pan or multispectral image matching process, and all the way up to multi-image author correction, image fusion, and also with true color output. That is where you can do the image fusion. And if the quality evaluation result shows that meet your preset requirements, you will be able to move further. But if not, you can choose to do some human-computer fine correction or to do some automatic fine geometric correction so that to achieve a better quality evaluation result. So after that, you will have to do the automatic or manual uniform light or color. So that is basically where you can tune the color, the light, the appearance of the image. And after the color is satisfied, you will be able to move on to human-computer interaction, the final step. And also you can choose to do the automatic image mosaic. And finally, you will have the results outputted in the standard framing output. This is a full workflow what you can expect in the satellite image processing workflow. But we're not going to do this much complicated in the case today. I'll show you a simplified one later. Up next, some features of PyAuthor. First one is with it provides an automatic or customized processing workflow. And the entire process can be completed in memory rather than in CPU or GPU, and that can help with the visualization of the output in real time. And it also supports the automatic matching and joint and block adjustment of large area multi-source images. And it also supports the uniform light and color with inbuilt modules. And it supports the customized or automatic processing workflow. And finally, flexible deployment model is also prepared. So we'll move to the first, that the whole processing process can be completed in memory and can be visualized in real time. So you can see there's a standard workflow displayed here that you are normally expected to start with the aerial triangulation adjustment and then move to the author photo correction, the image fusion, the mosaic and the uniform color, and finally output your product and then do the quality evaluation to determine whether this result is satisfied and can be used as a final output. And all of these, this entire process can be done in memory and in video memory, so that this will help to improve the efficiency and save storage in your computer. And also, in CPU and GPU mixed processing is applied to save resources and to enhance the processing efficiency. And also, the output can be displayed in real time, and also that can reduce a lot of input and output, which will also, on the other hand, save resources. The software also adopts an advanced three-level parallel processing method, which is between the data parallel, function parallel, and task parallel. And it also, the processing results will change in real time when parameters will change. And that is thanks to when everything is completed in its memory. And the third point is the I/O interaction is not required in the processing process, which is also thanks to all the process that is calculated in the memory. So after the point measurement is corrected, the correction results will be automatically displayed. This GIF shows display a normal example that when you are performing the process, that the real-time result will be displayed on the screen. That include from image correction, image fusion, and finally to the true color result output. And if you look closely at the window log down below here, you can see that for the image correction, it took 1.4 seconds. For the image fusion, it took around 4.2 seconds, 4.4 seconds. And for the true color output, it also took around 4 seconds. So relatively speaking, the speed is very fast and stable. The second feature of the PyAuthor is that it supports the automatic matching and joint block adjustment of large-scale multi-source images. What you're seeing right now is are two examples. The first one on the left shows that an image from Google Earth with 3-meter resolution, and the other on the right, it shows that from Terasar, the same location, the same image from Terasar, and using PyAuthor to do the matching for the same name point, and also perform the author photo correction. You can see that PyAuthor supports the automatic search and matching of the same name point in multi-images with different sources, different phases and resolutions. They can have those points extracted and matched. More examples. This one shows doing the same matching and joint block of adjustment for the same name point, and between the visible light image and the vector map image. And on the right, it shows the orthophoto. It shows the matching result after the orthophoto image correction. So you can see this PyAuthor is very powerful and accurate in finding typical ground features like the edges, the lines of the ground buildings or roads, especially for the same name point between different inputs. This image, another set of image shows more between the visible light image with 2-meter resolution and the lighter image, and also that the result is displayed on the right after the orthophoto correction. This picture shows we use 2 scenes of Golfin 1 image and 2 scenes from Golfin 3 image to perform the matching and block adjustment for the control point and the matching point here. So the final results are displayed on the right, where you can see the partly enlarged images. The overall errors of those images are controlled within 2 pixels. So as a result of this, you can say that PyAuthor, by using the automatic block adjustment technology, the PyAuthor can achieve the joint positioning and the matching for points from heterogeneous data, from different time phase, from different resolutions, which can greatly enhance the accuracy of the output. The third point is that PyAuthor supports the uniform light and color with inbuilt module. We call it the color uniform and the Mosaic editing platform. And PyAuthor supports the inbuilt module to perform the color uniform and light uniform, which is also a very unique point that we thought PyAuthor can distinguish from its competitors. This software comes with the editing tools for color tuning, for light tuning, for image mosaic and editing. It's quite like you're photoshopping your picture in PyAuthor, and it comes with a lot of parameters, a lot of factors that you can edit, you can change, and by using this, users can achieve the fine color matching. But on the other hand, they can also choose to use the automatic color tuning algorithms to, especially when they are dealing with color tuning in a large scene at a very large volume. PyAuthor also supports the color uniform and the mosaic editing platform by using the mosaic line edit function. You can see this in this function. It allows you to draw mosaic line, to perform mosaic lasso, to draw the mosaic polygon, or create a new mosaic line, and many others, and also to import and export mosaic line, and also set the feathering area, which is very important in the mosaic line editing process. Up next, it also the PyAuthor comes with a very unique human-computer interaction for uniform color. In this part, we have the development team of PyAuthor has, after a long research, they have come up with the best solution for mosaic line finding and researching. And it comes with this automatic generated algorithms for large-scale multi-remote sensing image as the input to create the best line for finding the mosaic line. And this allows users to automatically avoid artificial ground features and to find the best tuning, the best place to generate the mosaic line. That includes some manual color matching process that you can change the brightness, the contrast, the color scale, and everything you can think of when you're speaking of color tuning. And also, the mosaic line can be viewed in real time during the entire process when you are tuning this. Up next is the new function that comes in the latest version of PyAuthor, which is it allows users to perform a customized automatic data processing workflow, and that allows users it comes with a very rich algorithm library that users can call for from DSM framing, from image mosaic, and precise geometric correction, all the others listed in here. So as you can see in the interface of this one on the screen, in the picture shows right here, it gives you a standard workflow that it starts with generate connection point and generate control point and plane block adjustment, also rectification, and finally to output your image. But you can still change, and you can edit, you can change, you can eliminate, and add some more steps into this workflow and create your own. And on the other hand, you can also save your workflow and share with the others. This is very important in the actual data processing and result production, because once you have a very mature result and you have all the preset parameters are all set to go, you can share with the others that they can do the same on their computer, and with the same input can quickly generate the same result. Up next, number 5 is PyAuthor comes with flexible deployment modes, both from the standalone version and the cluster version. We have previously introduced this, so I will not go any further. In its typical applications in different industries, PyAuthor has been applied in more than 50 industries, and that include, such as in land resource management, PyAuthor can help users to perform the geographic condition monitoring, the natural resource investigation, construction land monitoring, geological and mineral mining monitoring, and so on. In agriculture, it allows crop monitoring, agricultural disaster monitoring, and many. And that also applies in forestry, in water resource management, environmental protection, and in traffic and road network supervision, in ocean or marine resource detection and monitoring, and in disaster risk reduction, and many other industries. Up next, I'll move to the second half of the introduction to the software, some of its latest characteristics and the strengths in the latest version of PyAuthor. The first strength is with its supportability for multi-type of data. It supports multi-source remote sensing data and mainstream satellite sensors, such as for the low-resolution series. PyAuthor supports the Landsat series, the TEM, ETM series, the Huanjing 1A and 1B series. For medium resolution, it supports the Spot series, the Rapid Eye, the Gaofen 1 series, Tianhui series, Ziyuan 3 series. And for high resolution, that include the Gaofen 2 series, the QuickBird, the WorldView, GeoEye, Ignos, and other types. All of those can be supported by PyAuthor. And on the other hand, PyAuthor also can automatically recognize the type of sensors that you are using as an input, and also support the batch image import. The second strength with PyAuthor is it supports the automatic search and matching for the same point. So the search and matching for the same point in image processing can very largely decide the accuracy of the output results. And that's where PyAuthor would like to focus on. And after a very in-depth research into this technology, PyAuthor now comes with a very powerful capability of searching for the same point, especially in heterogeneous data input. And by using the multiple strategies to enhance the computing capability of the computers, and also that combines with the technologies such as to ensure the different time phase, different resolution data can be searched, can be processed in here. PyAuthor now can perform the automatic block adjustment, and also supports the edit and input and control of the imported control point. So as you can observe from the pictures, the one on the left is a Gaussian 1 panchromatic image with 2-meter resolutions, and the same on the right is an image from Huanjing series, which is also a multispectral image, but with a 30-meter resolution. So you can see there's a 15-time difference in the resolution of the two images. But you can see the point recognized, the GCP 157, is located and matched quite perfectly between the two images. The next strength is with its self-adaptive RPC microfacet model, which means it supports the construction of self-adaptive RPC microfacet model in PyAuthor. There are always some types of data that can be difficult to process when you are dealing with actual data processing. For example, in the parameter models from some certain satellites where you don't have a very strict RPC model as a reference, and on the other hand, also some from the unevenness of the geometric accuracy from inside the data. So all of those can create a lot of difficulties when you are performing the traditional RPC model correction. So in order to deal with these kind of situation, the PyAuthor provides a function we call it the self-adaptive microfacet model, which can use the irregular triangular, use the control point to build the irregular triangulation network, and the nest with the regular grid to do the interpolation inside the module, inside the model. And that is to say, each parameter model is different within each pixels, and so that can achieve the real RPC model self-adaptive processing. Up next is with its true color descending stretching for uniform color. So normally in the actual work process of dealing with processing satellite images, the most energy and human consuming process is always with the uniform color process, and that usually requires a lot of experienced personnel, and they also have to work very long to have the final result to be tuned and more preferable for our naked eyes. So in order to make this process more automatic, more simple, and with a more acceptable result, this PyAuthor also come up with a solution that supports the the automatic color tuning. So up next, we have three key technologies that can form the automatic color tuning product lines that allows user to do so. The first is the true color descending stretching strategy, which can meet different requirements for color uniform. This means after the de-stretching processing and also based on the calculated ground features such as that for the vegetation, for water bodies, for air length, I also can give them colors and make it more preferable, like what we can expect, what we can observe from our naked eyes. And there's a very perspective example displayed here where you have the Golfin 2 panchromatic image on the left, the Golfin 2 multispectral image in the middle, and after the image fusion, there's some result. After the image fusion, there's a result based on the Golfin 2 image, and this picture shows the true color image of the Bird's Nest Stadium in Beijing, China. And you can see that the result on the left is very good looking, very close to what we can observe with our naked eyes, with the vegetation in green, the building normally in white, in gray, which means they are in the correct colors. Up next, in terms of the true color output, if users are not satisfied with the color output, like due to the radioactive or some other reasons, what we can do in here is to use the geographic template for uniform colors to meet different requirements by the users, and that can help to like reduce the sample rate and have them joined together, and which will be more preferable for tuning with small area of images. On the other hand, in case that you already have a historical color tuning preference, you can directly use that as a template, and that I also can use that as a template to batch mapping and to project that on the image that you are working on, so that you can reach a very preferable result automatically. The image shows that we used a 20-meter resolution image as a base map and project the true color result automatically. And you can see after the tuning, it's much more better looking. Up next is with this block uniform color function. So after previous steps with the true color output, the absolute accuracy of the image is normally acceptable already. But on the other hand, the relative accuracy can still use some tuning, use some adjustments, so that to make sure that the adjacent area, the image mistake, is completely is normal and acceptable. So we can in here use the uncontrolled block uniform color function to do the color tuning. For example, if we have a brighter image and a darker image, if we are going to perform the non-controlled automatic color block uniform color for it, the lighter point will become darker, the darker point will become lighter, so that they will meet in mutual in the balance in between. But if we choose the lighter image as the as a control reference, the lighter image will remain the same. The darker, on the other hand, the darker image will become lighter so that they can choose, they can achieve the better smoothing result in the final outcome. And this is exactly what we can expect in this function. You can observe that from the example given on the screen that before and after the block uniform color. You can see after these steps, the adjacent area, especially between pixels, between blocks, are much more preferable and very close to what we can observe from above on the satellite with our naked eyes. Up next is with the intelligent generation of optimal mosaic line and editing process. So by using this mosaic line finding strategy, PyAuthor can automatically avoid artificial ground features and find the best smooth mosaic line in the adjacent area. This can help users to do some manual editing in the partly tuned mosaic line to reach the best result that they are after. And beyond that, PyAuthor also comes with some commonly used color tuning and editing tools, such as that for curves, for hue, for saturation, and many others. And finally, other than high persistent DOM production, PyAuthor also comes with the stereo image dense matching capability in producing DSM and DEM. It can use the stereo image, satellite image, such as that from Ziyuan 3 series, from Tianhui 3 series, from WorldView, Golfin 7, from those satellites to complete the automatic epipolar image resample and have the dense matched DSM generated at a certain size. There's also an example displayed here on the screen that the picture on the left shows the rendering result for a 3D scene of DSM and DOM image based on the WorldView 3 data. Comes with a 0.3 meter resolution. And the other one on the right shows the DSM rendering result, which is based on the Ziyuan 3 series data. So that is so much for the introduction to the PyAuthor software itself. Up next, we are going to move on to the software operation, the actual operation in PyAuthor. But before that, I would like to clarify some basic concepts so that you can have a better understanding of what we have provided you, especially in the sample data and what you are expected to achieve by using the sample data and in the PyAuthor. Firstly, about the concepts. The first one is the author photo image, which is a remote sensing image with the property of author photo projection. So the raw remote sensing image can be highly affected by the internal status of the sensor, such as its optical systematic distortion or in linear scanning system due to that factors, and also can be caused by some external status, such as the schedule of the sensor and also of the ground situation on the Earth, such as the curve, the up and downs in the terrain. So all of those factors can cause, to some extent, cause some distortions in the raw image, and that is why we have to firstly perform to process it to eliminate the optical distortion. So in terms of the geometric correction on the remote sensing image, it can not only extract the spatial information, such as the plotting the contour of it, but it can also resample the image grayscale based on its geometric relationships and form new orthophoto image. Up next is the DSM, the digital surface model. It refers to the ground elevation model, including the height of surface buildings, bridges, trees, and many other ground features. So compared with another concept later on, the DEM, the digital elevation model, the DEM only contains the elevation information of the terrain, but not the other surface information. And the DSM is based on the basic of the DEM. The DSM contains more information, ground surface information, other than just the elevation of the ground information. And in some areas where the users have high requirements for the height of like the ground buildings, the DSM can be more preferable. The third concept is the DOM, the digital orthophoto map, which is an image database stored in the form of grid data by adding the information of topographic elements to the image plane. The DOM is normally based on the aerial photography or remote sensing image as the base, and after processing like the radiometric correction, the image mosaic, after those process to form in the like the image with how to say this, with image that clipped based on the size of the ground that you want to focus on. And on the other hand, it also comes with other ground features as symbols adding to the plane of the image, like it can be symbols, it can be lines, it can be nodes, it can be like kilometer grid or out towards or in towards that, adding to them so adding all of that to form the image database. It not only carries the geometric accuracy of the image, the DOM also comes with carries the image references, image characteristics. The fourth one is the geometric correction, which is a process that to eliminate the geometric distortion that is caused by atmospheric transmission, by the sensor, by the Earth's curve, and other factors. The geometric correction mainly corrects or gives image plane or coordinates. Other than doing some geometric correction, it also corrects the distortion that is caused by the curve, the up and downs on the surface, on the plane surface, and to add elevation information to the data itself to create the DEM. Up next is the geometric registration, which is to register an image to a reference image relative to a reference image. It is a geometric relationship between images. So that is when you compare the geometric registration between the geometric correction. The geometric correction normally correct the errors that comes along with the image itself, and also to add geometric coordinate information to reflect the actual case of the ground of the data itself. So you can say that geometric correction is more like a pre-processing to the data, but on the other hand, the geometric registration is more like post-processing to the image itself. Up next is the orthophoto correction, which is to resample the image into orthophoto by selecting control points and use the originally obtained DEM data within range to correct the inclination and projection difference of the image. This orthophoto correction normally mosaic different orthophoto image, and after the color tuning is achieved, it is normally it can be normally clipped out under a certain given pattern to create the orthophoto image. It has a very rich information carried with it and can be used as the data source for GIS, and it also reflects it's a type of being pattern that carries a lot of geographic information, system information, and so that can be used in this area. Up next is the DEM, the digital elevation model, which is a type of ground model that represents the ground elevation in the form of a group of ordered numerical arrays. So it's you can see that from its definition, it shows the it is actually a set of numerical arrays. So it used a set of numerical arrays to represent the elevation of the ground into a model which is called the digital elevation model, and it is also a very important derivative of the DTM, the digital terrain model. And there are some other types of digital information models that can be a derivative from this DEM. Finally, the last term is the geometric distortion, which is the difference between the geometry in the image and the geometry of the object in the selected projection, or the difference from the ground reality. So this is normally the geometric distortion is normally caused by the variation of the gesture angle of the sensor, the optical distortion of the lens of the physical sensor system itself, or the instability of the scanning speed, the self-rotation of the Earth, or the up and downs, the ground curves on the plane. So you can see that it refers to a geometrical distortion on the ground and caused by physics, caused by the Earth itself. So after knowing all these basic concepts, I believe you have a better understanding, and this will help you to have a better expectation than like what we can achieve in the given example, and the relationships between the different types of distortions, errors, or the results, the DEM, the DOM, DSM that we would possibly like to achieve. So up next, we may move to the software operation, which is to do the DOM production based on satellite image data. So if you have after this class, you can find all the information and the download links for the software, for the sample data that we provide for this exercise. You will be able to find that we use the Golfin 6 raw image as the input that we will focus on, and also it comes with its reference image and also comes with the DEM in the that contains the area. So this slide shows a general workflow of what you can you are expected to do in the later example. First, you will have to do the image mosaic based on the Golfin 6 raw image, and after that, combined with the reference image and DEM image as references, you will perform the orthophoto correction. And after that, it will be the precise geometric correction. And finally, the quality evaluation will be performed to determine whether you have reached, you have output the results that meet your preset requirements for accuracy. In the package, you will be able to find the data that we are using today. Is from the Golfin 6 wide Golfin 6 image, and also comes with other 2 reference image and 1 reference and 1 DEM. The location of that is in this area, in I think in Thailand. Up next, we will move to the software. And I'm going to play a video demonstrating to you how you can do this and what you can expect. And after you have the chance, after this training session, you have the chance to have the data downloaded and have the software installed and licensed. You are very welcome to do the same after this step by step after this process, and see if you can do the same on your own.
Hello everyone, welcome to PyAuthor software operation. In this video, I'm going to demonstrate a tutorial on DOM production based on satellite image data. I am Zhouwen Ma from PySet Information Technology Company. And let's begin today's course. In order to start the course, you will have to have the software installed on your computer, PyAuthor, and also have the sample data that we provided for completing today's course. The sample data contains 3 folders. The first one is the Golfin 6 folder, which contains the raw image data as the input for today's tutorial. And the other 2 named in base image and the DEM30, they are the reference image, the reference data of today's data processing, and is necessary in the upcoming steps. So the Golfin 6 ROM image will work as the data input that we provided. So, and this page shows the workflow of today's lecture. First, we will input Golfin 6 raw image, and since it is in different scenes, that the first step we will do is to match them together using the image mosaic function. And next, combined with the DEM data, we will perform the orthophoto correction. And also works together with the reference image, we will perform the precise geometric correction and quality evaluation at the very last end. And after we are satisfied with the quality, and we will output the DOM, the digital orthophoto map, as the output, the result of today's tutorial. So we will start with some introduction to the sample data that we provided for this tutorial. This sample data, the raw data is from Gaofen 6 satellite, which is a low orbit optical remote sensing satellite. It has some of the characteristics, such as it can provide high resolution data, it can cover a wide coverage in a scene, and also it has the high performance in imaging, and also it works very efficiently. The Gaofen 6 satellite is one of the first satellite in China that works for accurate or precise precise agriculture observation. It is one part of the Chinese major high-resolution Earth observation system, and together with other satellites from the Gaofen series, this Gaofen 6 mainly works on areas such as for agriculture, for forestry, for disaster mitigation, and also meet the requirements in environmental protection and in urban planning, in homeland security, and others. So what we are going to use today from Gaofen 6 is a scene from a scene of data in Thailand. As you can see on the picture on the right, some of the property of the data input we are using today, including the Gaofen 6 image, which is a multispectral image, contains 4 band, and the resolution of it is 16 meters. And in terms of the reference image we provided, it is also a multispectral image, 3 band, and the resolution is 9 meters. And up next is the DEM data, which is a single band data, and the resolution is 30 meters in the research area. And all reference image and DEM image are in the WGS 1984 coordinate system, which is one of the most commonly seen coordinate system. So up next, we will move to the software itself and start our tutorial. First, what we are going to do is the Gaofen 6 image matching. Since the Gaofen 6 image that we provided is sliced into 3 or 4 scenes, that first we have to stitch them together and using the image matching function. So we'll move to the PyAuthor software. First, click on the top left icon, and in New Project, we choose to start a new DOM project. There are also like DEM project and or some other general projects you can also start here, but the process is basically the same. So we will start with DOM projects, and in basic information, we can give our project a name and set the path for output. In here, I'm going to start a new folder and give it the same name as demonstration. And choose it, select it, and next. In the image information page, we will have to load the data that we provided, including the multispectral image, the DEM, and the reference data. So we will do that one by one. Start with the multispectral image. If you're working on a panchromatic image, the procedure is the same, but you have to choose another one. So we'll choose multispectral image, and load the Golfin 6 image we provided with this one. And next, add the reference image and DEM data in another 2 folders that we provided. So in reference image, we will find it in the base image folder. There's a TIFF format image named Thailand image. We choose it. And the same for DEM data in another DEM30 folder. There's a 30-meter resolution DEM data and in the same research area that we want to work on. Choose it, open, and then we can click next. So in the next coordinate system label, we will have to choose the coordinate system. And the most generally used in here is WGS 1948, and that is exactly what we are going to choose. So we will remain this page unchanged. And next. In this output config, you can manually select different paths for the production of any after any procedure, such as I want to save the multispectral orthophoto image in a different path. You can do that manually, but in here we're not going to change them. And after this step, you will see that all of those folders are created in the demonstration folder that I've just newly created for today's tutorial. And in here, resolution configure, you will have to manually change the, we're working on multispectral image, so you will have to manually change the multispectral resolution. So you can see this 0.00001 is equal to 1 meter, and the data we are using is 16-meter resolution, so you will have to change the 8 to 16. And then click on finish. I also will ask you to whether you want to create a pyramid or to calculate the histogram, which will take more time, but will provide some convenience for coming up procedures if you are working on a large projects or so. But we're not going to do that today to save some time. So click OK. Okay, so the new project has been created here. This is what it is shown after the new DOM is created. And up next, we will move on to the DOM process production, which is a very simple and one-click automatic process that we created for producing DOM output. It is under the process production label, and you will find the DOM icon. Click on it. We will move on to the DOM process production window, where you firstly have to choose the data source. And we have already loaded the data in here. It is multispectral image, so you have to choose that manually. Select it, and next. In the configure label, you can see there's a typical workflow that the PyAuthor have already created for you, where you only have to follow the procedure and finish each steps to get what you are looking for. So I will demonstrate them one by one. We'll start with connection points match. Since the data we use only contain one scene of multispectral data, so there's no need to generate a connection point in here. So we will choose skip, tick on this box, and skip the first step to create connection point. Next is the control points. There are some parameters you can set in the control points matching page. That includes such as texture quality, which is used to describe the texture similarity between images in the project. The default value is set at medium or middle, but you can set it to high or low according to what kind of data you have loaded for your own project. So there's the ignore valid option, which is automatically checked. The invalid value of the image will be ignored in the process of control point extraction. So we'll set this one as default checked. You can also use previous results, which is to say you can call for like error triangulation results if the data to be processed has been solved in previous steps, but we don't have that, so we will keep that in no. There's a do not output DEM invalid value, which is so when this option is checked, the DEM invalid value area will not participate in the calculation. And finally, there's an invalid DEM value. We can set that as 0 as default. Okay, and then move on to the block adjustment, the third step. There are also some parameters such as the adjustment method you can choose. You can choose either between the general or normal block adjustment method and the sparse control points block adjustment. So we will keep that as default. And next is the minimum errors in model, which is to set the minimum error threshold for block adjustment model. And the smaller value in this option refers to a higher adjustment accuracy. And the third one is the weight of control point, in which user can adjust the weight of the control points in block adjustment solution. So the default is set as 10. You can change it if you want to give more or less weight of the control point. We are going to leave these parameters unchanged here also. And the next, panchromatic orthophoto, we are not going to perform on any panchromatic image, so that is, you can say, in gray. We'll move on to the multispectral orthophoto adjustment. First, we will tick on this box, which is to say we want the this process production to output the results after this step. So if you tick on this box, it will generate a multispectral orthophoto adjustment result for you in the corresponding folder. There are also some parameters, such as if you have existed DEM data or you don't have it, you can choose it in here. The default value is set as yes. So if you can manually do an input and set the constant value for DEM. The next is it wants to know if you have the output invalid DEM value. If you check this option, it will display the set value. It will set the invalid value when calculating evaluation in DEM invalid value area during the data processing process. And there's another option in factor correction. So when this option is checked, the orthophoto output of the image will be carried out using the small factor correction algorithm. We're going to leave these parameters unchanged here today. And another point you can bear in mind, which is since we are only demonstrating typical process and using typical sample data that we prepared for this process, so most of the parameters I'm not going to change them in the demonstration, but in actual project production, you can, if you are not sure about which parameters you are going to go with, you can leave them unchanged as default and output the result and see if that satisfy your requirements. And say if you want to change, such as the texture of your input, the outcome, the accuracy of the outcome, you can go back to the first step of this DOM production process and change the corresponding parameters to get what you are looking for. So the subsequent process is irrelevant with the demonstration case for today, so I will not change the settings in such as true color image output, auto uniform light, or auto uniform for color, the auto mosaic. I will leave the upcoming procedures unchanged and click on OK. You can see now the DOM workflow has begun. It is now doing the procedure. Okay, so now the DOM workflow has been finished, and we click on OK. After this step, what we are going to do next is the quality evaluation. So we will click on the quality evaluation label and start with the accuracy inspection. In here, we first we will have to choose the work model. It is set as full automatic in default, which is going to which is to say the input image to be inspected and the reference image must have the general projection information, and the geographical proximity relationship can be automatically generated according to the projection information. And then the data type, we have to choose multi-image, which is what we have been using for this tutorial, and load it. Let's wait for it. We'll take some time to do the quality evaluation. Okay, now the quality evaluation has been completed, and we will see the quality check map displayed on the screen. And up next, we will generate checkpoints. In here, in the check image management label, there are a few icons that you can choose. So we will go with the first one to generate checkpoints. It will be in the checkpoint generation interface where you will choose the data, the multispectral image that we loaded. There are some other parameters that you can fix, such as the texture quality, the geometric evenness, and you can set that as default if you're not if you're not clear about the data you have been using. But if you know better, such as I'm using a high texture quality data, you can choose that in corresponding options. And the preset seed amount is 1,000. You can also leave that as default. The more checkpoints you choose, the longer time it will take to generate those. But it will assure a better accuracy in the final results. So it's a balance between the time taken and the accuracy that you want to balance. We will leave the parameters unchanged here and click on generate. So the point has been generated. You can see it has 143 checkpoints. And in the checkpoint management label, you can see all the points, 143 points, and their parameters such as their x coordinate and y coordinate and the reference and the deviation. What we are going to do next is to manually edit the checkpoint. So in the checkpoint management tab, there's some there are a few options that users can choose, such as you can batch select, and it will ask you about your standard of setting those points, such as in XY deviation. Click on it and say I want to eliminate the point with large errors, with large deviations, such as the XY deviation is larger than 1. We normally will remove those points, for they will normally carry large errors. And hit OK. Since we are doing the checkpoint generation quite perfectly, there are no points fitting that XY deviation larger than 1, so you can see it doesn't choose any. But in actual case, in actual project that you worked on, you can do this to batch select to first help you to filter the point with larger areas and remove them to ensure a better accuracy in the final result. You can also manually edit those points, such as when you click on one point, it will in the map it will automatically locate to that point. And you can also manually select those points. There are tools here, and you can manually edit the point. When you click on it, it will show the point where the point is located in your reference image and in your input in your raw data. And you can right click when you say you are not you don't think the point can will be located here, and you can click on right click on your mouse to set a new coordinate, set a new place for this point. And the same can be done also in the reference image. Okay, so we'll close it. After this, you can also perform the precise geometric rectification. So on the top left, and in data type, you will choose multi-image for today's tutorial, and click on the image. And there are a few parameters you can set, such as the extraction object from feature point, which means user can select from the corrected image or the base image. The object texture can be standard, can be high or low according to your loaded data. The correction mode, you can either do it in the geometric polynomial mode or others. We'll set this as the default mode. The output projection, where you can choose that in uncorrected images or according to the base image. Feature point number, you can manually select that by preset the number of feature points to be extracted from each scene. Normally, a larger view in the feature point number will assure more matching points with the same name. And there's a polynomial model start removing the gross error point, which is for the users to set the residual threshold for of the polynomial model, and which will automatically delete the checkpoints with residual values greater than the threshold in the automatic matching procedure. We will leave all the settings unchanged here and click on OK. Okay, so the precise geometric rectification has been completed, and you can see the result in the main menu. In here. What else you can do after this step is in the quality check label, and there's a tool of swipe. When you choose that swipe tool to check for the checkpoints, you can click on your mouse and hold and see the difference between the upper layer and the bottom layer. In this case, your image and the base image, and see if there's a difference, such as in this area. When you enlarge and hold and swipe, you can see the difference between the upper and the bottom layer to see if the two layers has been perfectly matched. If they fit with, if the two layers fit with each other very perfectly, that is to say the precision of your result is acceptable, is very good. Okay, so this is the end of all that we want to achieve in PyAuthor. So after all these steps, you can observe your results in the folder you have just created, such as in the DOM folder. If you see that after panchromatic, and we didn't output that, in the quality check, you can see this is the result after quality check, and you can use this data to do some further development, such as load these into PyBasic to do some feature extraction, to do some calculation or so, and output your report. And also, we didn't tick the box, so there will be no result saved in after, such as after image mistake, but you can tick that in the DOM process protection workflow and output it. It will be saved in these folders. Okay. This is the end of the tutorial of how to use PyAuthor to perform the DOM protection based on satellite image data. Thank you.
Okay, so this is the end of the operational part, and I would like to once again emphasize on the document that I will share and upload to I'll also upload the document to the UM model space where you should be able to find access to. Again, in this document, you will be able to find all the information you need to have a better understanding of what you can achieve in PyBasic that we have introduced in the morning, and also in PyAuthor that what we have achieved just now, and also in the two sections, including the PyBasic, they all comes with the training package, the package with including the installation file of the softwares themselves, PyBasic and PyAuthor. Also comes with a user manual for both two modules that you will have. You will be able to find more information like instruction to all of the functions and some guidance or typical questions that you might encounter while using the software. Everything you need to know are in the manuals. And finally, also the sample data training that we demonstrated today, including the one that for DOM production that we have just gone through, but also for the PyBasic module which we didn't go through. It is for their using the remote sensing data to perform the vegetation coverage extraction and distribution description using PyBasic. And also, this instruction also gives you the links to download all the softwares, all the software, and also tells you what you can expect with the performance of your computer, so that you can smoothly use the software. And also give you instruction on how to install and how to have your software license. You have to pay extra attention to this part, in which you will have to send us your personal information so that we can provide the trial license to which will allow you to use the two software and to have the homework done. And finally, some instructions and the commonly asked questions while using the two software. And finally, for further technical support, you can contact me or contact our company, and also find more information on our website. So this document will be shared later, and I'm sure you will all have access to this one, so that you can complete what we have achieved in PyBasic and in PyAuthor. Okay, this is the end of this section. I think we will take around 15 minutes break, and after that we will move to a brand new part introducing our cloud, remote sensing cloud platform named PyEngine. I'll share more information with you later. Thank you.